Yeah, hi all. So welcome to the course again. So we are starting with some traversing algorithm of graph, which is BFS and DFS. So in tree we have a pre-order, post-order, and in-order traversal. But in case of graph, you know that it's there are cycles in the graph, right? So to traverse it, we have specific algorithms. And then once these algorithms are basically created, then lots of application of those algorithms got created. The first one is depth first search, DFS, depth first search. So I will see connected and disconnected both the graphs, right? And in that case, you will see how depth first search algorithms works. Then we will write down. Then we write down the algorithm steps for that also. Okay, once you understand it, you will see that why depth first search use stack. Now, okay, not stack, stack. Stack, okay. We can use two types of stacks. One is system stack. It means without using explicit data structure stack, we will use recursion. Recursion here, okay. So in case of recursion, what happens? It will use system stacks automatically. Recursion, okay. So we will see both, like most probably the recursive algorithm where we don't have to use explicit stack. It will be using system stack, okay. So you don't have to define any stack here and there. You just have to create one visited array. So let's see the algorithm in action here. Okay, so let's take an example, very simple example where we will see the algorithm. So let's see a tree. Okay, depth first search, and let me clear it, DFS. Let's see a tree here, which is basically this one. 1, 2. This is a directed tree. Oh, no tree, sorry, graph, directed graph. Let's see this algorithm in action. 3 and 0. From 0, we have add to 1, plus to 2. And we have a loop on 3. And from 2, we have 1 adds to 0. Okay, so these are the basically edges, and we have 4 vertices. Now, what does DFS says? It says that we will traverse each node only one time. Only one time. Okay. So once we pick a node, we will go in the depth, as much depth as possible. Okay. If we miss any node, we can pick, if we have multiple choice, we can pick any node and we can go into the depth, and we will see if it covers the graph. If it don't cover, we'll go back, which is like backtracking. We go back and check what did we miss. Okay, so let's start. For example, here we are starting with 0. Okay, so let me use a stack here. Let me use a stack here. So initially we put 0 in the stack, which is the starting point. You can pick any node as a starting point. It's your choice. We'll use 0 as a starting point, and we will use a visited array, or you can say hash map, which says that whether this is visited or not. So 0, 1, 2, and 3. Initially visited for each node is 0. Okay, so it's 0 here, 0 here, 0 here, 0. 0 means it's not visited, 1 means it's visited. So from whichever node we are starting, we put that into the stack. Okay. Once we pop it from stack, we say that, okay, this is visited. Okay, so whenever we are pushing it into the stack, we say that it's visited and we won't go there again. Okay, so we are starting from 0, we push it into the stack and we say that, okay, it's visited. The value here is 1, it's visited. Okay, so first step is push starting node in stack and mark it as in stack and mark it as visited. Okay. Now, in the next step, we pop the topmost. We pop the top. We only pop the top. Okay. So we pop the stack. We pop the stack and push its children into the stack if those are not already visited. Okay. So let's pop the 0. Once we pop the 0, what all its children are? Its children are 1 and 2. Okay. From 0 to 2, we have a edge. From 0 to 1, we have an edge. So we push 1 and 2 into the stack and mark them as visited. Mark them as visited. While pushing, we are marking them. We mark them as visited. Okay. Now we have cleared this one. We have cleared this one. Okay. Now we'll see that from 2, where can we go? We can go to 0 or 3. 0 or 3. Now 0 is already visited, so we will push 3 here. We'll pop 2, check all its children. Whichever is not visited, push it into stack. We'll push 3 here. Okay. So what is the visiting sequence? 0, 2, then 3. What is the pop sequence? Whichever is the pop sequence, those are the, you can say, in whichever manner we are popping from the stack, those are the traversing pattern we are following. That is the traversing pattern. So the traversing pattern is 0, 2. After that, the top of the stack is 3. So we will pop 3. It means we note it down here that this is being traversed. We'll write down 1 here in the visited of 3. What all children are there of 3? The children of 3 is 3 only. Okay, it have a self loop, but that is already visited, so we won't push it into the stack. Now see here. So this is the depth we are going into. We are going from 0 to 2, 2 to 3. Okay, so that is the maximum depth we can achieve. We have achieved that depth. Now what is the backtracking here now? The backtracking is, we have already pushed 1 into the stack. We have to go back to the 1 again. We have to go back to the 1 again and check its children and 1 also. So then we pop 1 and we write 1 here. So let's take a more complicated example. This is a very easy example. We have visited. Okay, and let me basically open up a, let me basically write down a complex DFS example. Okay, my computer got hanged. 1 second, guys. It's yeah, let me draw through my understanding only. 0, 1, 2, 3, 3. Okay. 4, 5, 6, then we have 2, then we have 7 here. Now let's see how this one is getting visited. Okay, so we have a visited array. Let me draw an array like this: 0, 1, 2, 3, 4, 5, 6, and 7. Initially, all have 0. Okay, or you can say it's empty, so it's not visited. We will write down 1 here. It means that is visited. Initially, nothing is visited, and on stack is also empty. Okay, so this is a traversing pattern. We'll write down here. Now we will put the starting point, which is, we are assuming that it is 0. We can start from anywhere. So it is 0 here. We pop 0 and we mark it as 1. It's visited is 1. Once we push it, we mark it as 1. Okay, it's already visited. Once we pop, we say that, okay, this is traversed. Once we pop, then only we say that it's traversed. Okay. Now what odd children are there? We'll push it into stack. We'll push 7 here. We'll push 1 here. We'll push 2. In any order we can push. Either we can start from here to here or here to here, right? We can push 7 to 1 or 1 to 7. Doesn't really matter. The order doesn't really matter. Okay. Now the top of the stack is 2. The top of the stack is 2, right? And we mark these 7, 1, 2 before popping. We mark 7, 1, 2 as visited. 7, 1, and 2. These are visited, right? Already visited or present in stack. Now we pop 2. We say that, okay, we have traversed 2. Now what all children of 2 are there? It's 3 and 4. So we push 3 and 4 here. Push 3 and 4 here, right? And mark 3 and 4 as visited. 3 and 4 as visited. Now we pop 4. We write down 4 here. That, okay, this is visited. And we push its children. The only children is 5. If it's all not already visited, then only we will push it. We always check once we pop a node from the stack. We check what all children are there which are not visited. Only those children will be pushed here. Not visited in the visited array or visited hash map. So we push 5. Okay. Now we pop 5. We write down as, okay, this is traversed already, or we can print it, return it. We mark 5 as, okay, already visited. Now what all children of 5 are there? 6. Only 6 is there. 6 is not visited, so we mark visited as 1. We push 6 here. Okay. Now we pop, because in stack we can only pop the topmost. We cannot pop anything else. We pop 6. We write down 6 here. 6 don't have any children, so it is visited. Now see here. See the path. We are going to 2, then 1, then 4, then 5, then 6. We are going into depth. Other nodes are not being traversed yet. Only this path is being traversed. Other nodes are there in the stack. Okay, but they are not being traversed yet. Unless we pop it from stack, they are not being considered as traversed. Okay, visited means we have gone through that children. It's in stack. We will process its children later on. Okay, so that is depth first search. Depth first search is go into the depth. Now here check. Now we will pop 3. This is the topmost. It means that we are going back to 2 children. We are going back to 2 children, 3 here. Okay, we are going back into the path and then checking 3. We are going back into the path and then checking 3. So this is backtracking. We have explored a path. Okay. We have explored a path. Now we are checking 3. Okay. Now we pop 3 and we say that, okay, 3 is being traversed. Now we pop 1 and we say that, okay, 1 is being traversed. Then we pop 7 and 7 is being traversed. So that is the way of depth first search. It always search into the depth, then go back, come back. Okay, so if you check check a graph which looks like this, okay, so it is a graph, right? We have a cycle here. That is why it is a graph. In tree we cannot have a cycle. I'm trying to make it like tree because to make you understand depth first search. Okay, now see what will happen. Let me mark them also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now the use of visited array and stack I already have given to you. Now let's see how this will go. Okay, let's start from the beginning. So it will go like this. First it will traverse 1. Okay, traverse 1. Then it will push all its children into the stack 2, 5, 3, 4, or we can use the recursion also. Okay, so for example, if it's pushed 2, if it have seen 2 first, 5, then 3, then 4, then the top of the stack is 4. Now it will make it traverse here 4. Okay, it will push 4 here, then it will traverse 11. Okay, so see how it is going. It is going into the depth, as much depth as possible. Using this link, it will try to cover as many children as possible. Okay, then it will cover 10. Now 3 is already in stack, so it won't go to 3. It will go to 9, right? Like this. Then it will say that, okay, from 9 I cannot go anywhere. This is kind of dead end. So I have to go back again to 1 and check its other children. Okay, this is the behavior I am saying. This is the behavior. This is how DFS is running. The implementation or the way it's running, we have seen that it uses a stack and a visited array. No issue. But this is how it traverses. It goes into the depth. Like it will first see from 1 to 4. It won't check 3 after that. It will see more children of 4. Okay, then in 10, then 9. Now, if this is the backend, it will backtrack to the 1 because from 10 there is no path, from 11 there is no path, from 4 there is no other path, from 1 there is no other path. From 1 only we have alternate to 3. It will go back to 3. From 3 there is no path. This is already traversed. This is already traversed. This is already traversed. This is already traversed. There is no path, so it will go back to 1 again. Okay, and it will check. It seems like it will go back to 1 again. Okay, the stack works like this. Now from 1 it will say that, okay, there is no path remaining. It is already traversed. Okay, now let's go back to 1 and check other children. It will go back to 5. From 5 it will try to go into the depth as much as possible. It will go to 8. Okay, then from 8 there is no other way. There is nothing to go. It will go back to 1 and check other children. It will go to 2, then 7, then it will check depth, full depth, 6. This is how DFS works. Sometimes they give you a complex graph, directed or undirected. They ask you the possible DFS, traversing. Okay, let me consider an example here. A, B, S means source, C. There are many possible ways, but let me tell you which is not possible. E, F, G. Okay, so now we are saying that we are starting from S. What could be the possible way, DFS scenario? Okay, so let me tell you one possible DFS traversal. Okay, then we will see which is not possible. Okay, see here the example S, G, H, E. Then after that we have F. Then we have C. Then we have D. Then A. Then B. This is one of the possible ways. Okay, how come? We will from S we will go to G. Then we will go to H. then we'll go to E. Okay. After E, basically, C is already there in the stack. We'll go to F then. Okay, C, F. We'll go back till G and check. From E, there is no other way. There is no other way from E. There is no other way from G. Okay, there is no other way from G. So we will go till G, and check F. Okay. If we don't use stack and we use recursion and the visited array in the recursion, then what happens? Let me write down the algorithm. Then this is also a possible way from S to G to H to E to C to D. This is also one of the possible way. I have written the DFS in one of the way in which we mark the visited once we push it into the stack. Okay, once we push it into the stack, we mark that. Now what we are doing, we are using some recursion. I will write down the algorithm also. Here we are going like S to G, G to H, S to E, E to C, C to D. Okay, so we are basically going like this. Okay. We are exploring as much depth as possible. Okay, like from S to G, G to H, S to E, E to C, C to D. Now D don't have any other way. So we'll go back to C. From C to we can go to F. Okay, this is explore. Now from F we don't have any way because G is already explored, H is already explored, E is already explored, C is already explored. So we'll go back to S. This is backtracking. From S we'll go to A and B. Okay, so what are the DFS possible way here? From A, S we can go to AB also, S, AB. Then we can go to C, D, C, D. From D we have to come back. This is one of the possible DFS. E, H, okay, E, H. From C we can go to E to H to G to F. E, H, G, F. This is one of the possible DFS. What's not possible? From S you go to C. Then after C, don't explore the depth. Okay. Instead what you did. Okay, this is not the possible DFS. Not the possible DFS. Which one? S to C. Then suddenly you jump to A. Okay, because C have further scope to explore, which is not already visited. So it will explore the depth. Okay, so C can go to D. Now D don't have any other way, nowhere to go. So we go back to C, and from C we can go back to F or E. For example, we can go back to E. Okay, from E we can go to H, G, F. Okay, so we will explore the depth as much as possible. Okay, until we stuck somewhere. From there we cannot go anywhere. Either all the paths or all the nodes are already explored, or there is a dead end. Then we go back till we find a alternate path. For example, here, if we go from S to C to D, C, D have dead end. So we'll go back to C again. From C, we have two paths, either this path or this path. DFS can pick any path. If DFS pick E, so it can go to E, H, G, C. From E to H to G to F, it can go to F also, okay? And if it pick F, okay, after D, there is nowhere to go. So from C, we cannot go back to S, right? S is already visited. So we can go to, if you pick F, like F, then G, then H, then E. From E, there is no way to go anywhere else. So we'll go back till, where? S. From S, we have this one more path remaining, A and B. So this is a possible DFS. Okay, so whenever they give you a question whether this DFS path is valid or not, you have to identify how am I exploring this. Okay. Am I going into the depth, or before going into that depth, I have chosen some other path, which is not possible now as per the DFS algorithm. So let me write a DFS algorithm with recursion. Okay, with recursion. Okay, so let's see DFS. Okay, we provide the source. This is a source vertex from which we are starting. We provide visited, which we don't have to add to stack or explode again. So this is a recursive algorithm, which is more neat actually. So initially we add visited, we add basically we add this S to visited set. Okay, so that we don't explore this again. It can go into the loop if we don't add this S to visited, right? And we say that, okay, print S is done. It is traversed. Now we explore all the neighbors of S, or all the neighbors, or you can say children. All the neighbors of S. If this neighbor is not visited, it means it's not being visited already. Then what do? We do DFS again on the neighbor, and we pass the visited array. That's it. That's it. This is the DFS algorithm. Very simple, without using any data structures. Because we are calling the same function recursively again and again. Okay. Until the current node have a neighbor which is not already being visited, it means it have a path where the vertices is not being explored, it will go to that path. Okay. It won't basically mark the existing children as visited. It will explode in depth first. Okay, so this is the algo. That's it. So the stack that I've explained, that is being used by system to manage this recursion. Okay. This is the DFS algorithm. We will see its application. I will write down the name of all the applications which they ask in the various examinations. But before that, we will also see DFS, okay, in the next lecture. So I am keeping this lecture very small so that you can go back and basically, if you have any doubt, you can go back and check other examples, GATE examination examples of DFS. Those are very easy, very straightforward questions. Please go back and check. After clearing DFS, I will tell you the applications of DFS and BFS. Okay. Thank you all for joining.